So today we will talk about methods of vector addition. But before moving, we will talk about the scalar addition and the vector addition. So first of all, we'll look at scalar addition. Like how does a scalar addition actually looks like? So what happens in scalar? For example, if I'm adding 5 kg of mangoes plus 4 kg mangoes, the answer would be, obviously it is pretty obvious that the answer will be 9 kg mangoes, right? The answer will be 9 kg of mangoes. Here nothing affects, no angle, no length, only there will be the actual mass. Like mass is a scalar quantity, right? This is mass, right? So mass is a scalar quantity, and when we add two scalar quantities, we will follow the same arithmetic rules. We will follow the same arithmetic rules. Right? But when we are adding vectors, right? Let's come here. But when we are adding vector, or vector addition, right? So when we add vector, for example, there is a girl who is moving 3 meter east, right? I hope that you know these directions: north, south, east, west, right? So if a girl is moving 3 meter to west, and then she is moving again 4 meter to east, so what will be the, now how much displacement does she has covered? So we have to tell the displacement, right? Like what will be the displacement over here? So displacement will be 3 plus 4 is equal to 7 meter, right? There will be 7 meter of displacement. But what happens if the girl moves, like if she's moving first in 3 meter east, right? First she moves 3 meter east, then she is going, like her mood changes and she wants to go somewhere and she wants to shop something. So she's again coming back 2 meter west. So she's again coming back 2 meter west. So now what will be the displacement? What will be the displacement? So what is displacement? Displacement is actually the shortest path, right? From position 1 to, for example, from position 1 to position 2, the final position to the initial position, actually from initial position to the final position, or you can say it is the shortest distance. So right, so here the shortest distance will be here, this one, right? So now here 3 plus 2 is equal to 1 meter, right over here. But now what if a girl is there and she is moving, first of all, 4 meter in east, right? Then she is moving 3 meter in north. Now what will be the displacement? So over here, what is displacement? Displacement is the shortest distance from the final position to the initial position. So basically over here, what will be the displacement? So over here, when we add 4 plus 3, the answer will be 5 meter, not 7 meter. So it means that in vector addition, if we add 3 plus 4, the answer can be 7. If we add 3 plus 2, or you can also add, for example, let me change this value. And consider this as 3. Now it will be easy for you. Now consider it means in vector 3 plus 4 can be 7, 3 plus 4 can be 1, and 3 plus 4 can be 5 too. So it which quantity, it really depends. So it depends upon the angle. It depends upon the angle, right? So 4 plus 3 can be 5, 4 plus 3 can be 1, and 4 plus 3 can be 7 in vector addition. But in scalar addition, it won't, like, we will use our algebraic rules, arithmetic rules over here, right? So now let us discuss the methods of vector addition. Methods of vector addition, right? So basically there are 3 methods. First is known as triangle law. Triangle law of vector addition. Okay, today we will only look at the second one is triangle. First is triangle of vector addition. Second is parallelogram. Law of vector addition. So today we will only look at the geometrical method. We will not move to the analytical method, and that will be on the all the formulas will be in the next video of the analytical method, but here it only contains a geometrical way. And the third one is polygon law. Polygon law. So now let's talk about first triangle law, right? So in triangle law, what we actually do when we consider this is a triangle, this is 4 meter, and there is another vector moving upside that is 3 meter. So now, okay, if you want to add these, right? So what will happen if two vectors are represented? Like if two vectors are represented by two sides of a triangle, right? These are both two sides. This is a side, right? This is also a side in magnitude and direction taken in same order. Like the magnitude and direction is taken in same order, like how it is attached head to tail. Head to it is attached head to tail. How? Look at this. How it is attached head to tail? Like this is the head, this is the tail, and the head is attached with the tail. So what if two vectors are represented by two sides of triangle? Obviously these both are the two sides of the triangle in magnitude, and direction taken in same order, like the direction is taken in same order, right? So the head, this is the tail. Then the resultant, like the answer is given by the third side of the triangle. Answer will be given by the third side of the triangle in a magnitude direction taken in opposite direction. Now this will be wrong. Why? Because it should be in opposite direction. It must not be in head to tail. The resultant must not be in head to tail. So what will be the correct answer? Doing this in opposite direction. So this is known as resultant vector, which we are not known, right? So what if two triangles are represented, like if two vectors are represented in a triangle side with magnitude and direction with the same order, right? They are attached head to tail, and the resultant will be attached in the opposite order, right? It will be attached head to head. So let us talk about vector A plus vector B is equal to resultant vector. Now the magnitude of the resultant vector, the magnitude will be shown by the length, right? The magnitude will be shown by the length. But what about the angle? What about the direction? Like it is a vector quantity, right? So what about direction? It will be shown. So consider over here there is an angle. This is an angle, right? Theta. Okay, or you can consider this as a alpha. Angle alpha. So what will be the direction of the resultant R? The direction will be alpha with respect to A. You will understand this thing later on in this video, like what does that mean. So in the resultant vector, the magnitude will be equal to the length of the line, okay, and the direction will be equal to the alpha with respect to A. So what is A? A is over this. This is A is equal to 4 meter, B is equal to 3 meter, right? So this is this. So let us do one question over here, that if consider that there is a girl who is moving 3 meter in west, right? She is moving 3 meter in west, then she is moving 4 meter in north. Now we have to tell the resultant vector, right? So obviously the resultant vector will be in opposite order. This is the opposite order. How we will solve this now? It is a very common triangle, so I'm pretty sure that the answer will come into 5 meter. But how I did this, let's talk about that. So there is a theorem known as by Pythagoras theorem, right, over here. Now over here, h square is equal to p square plus b square, or h is a resultant vector, p is 4 plus 3 square. Now r square is equal to 16 plus 9, r square is equal to 25. Now we will take the square root. will cut this square will be cut from this, right? So we will cut this like this, right? And the square root of r will be 5, right? This is what I said, that 5 will be coming over here. Now, in which direction, right? So let's first of all make the directions, which will be like this: north, south, east, west. So where the triangle is actually triangle over here, and it is moving like this, right? So it is north of east. Basically it is east of north. Wait a minute. As you can see over here, if I placed this triangle over here, let me not to draw this. This is like this, right? Now the angle between this, tell the angle between this. So then it will be equal to east of north. East of north. Now I have to tell the angle, like what will be the angle over here. So there is an easy formula for that, which is, you can easily calculate theta is equal to 10 minus 1 fy upon fx. So this is a formula which we got from the resolution of vector, right? But simply you can learn this thing that it is very common triangle, right? This is very common triangle. Remember this thing, that if this is 4 meter and this is 3 meter and the resultant vector will be always 5 meter, then the angle over here, right, this is 3, this is 4. Now the angle over here will be 53 and the angle over here will be 37 and angle over here will be 90. This angle is 37 degree, this is 53. So over here we are having 3 4, right? 3 4. So over here the angle will be 53. So answer will be 5 meter east, 5 meter of 53 degree east to north, right? This will be the answer. So I hope this is clear to you.